Good morning, Alan.
Good morning, Mitch. How you doing, sir? Just so we've got it. So let me share my screen. One. So can you see it there?
Yep.
Yep.
A bit bigger. So there. So new frontiers draft technical requirements. And that's the one you've got, right, Mitch?
I do. This is the one I saw a couple.
Yeah.
I guess it's
Okay,
2 weeks
good.
ago. Yeah.
Good. So
You sent it to me, right? Right now, I still didn't see it.
Yeah.
You sent me a Google email or my latest email?
Good question. I sent it to you.
Where's my Google email or something?
Oh, hang on a minute. I sent it to you. Where did it go then?
Yeah, for some reason I'm not getting. I got normal email, but not this one. I didn't even
no, you wouldn't have got this for some reason. It's not even. I can't see it in my outbox, in my sent box. But I definitely sent it. It's a pain in the butt. This is maybe this is why I'm not getting any responses.
Yeah.
I think I've sent stuff and it doesn't.
Yeah, I didn't see this one, so maybe here.
Joey RSD. Let me just try and send it again. Actually, cancel that. So it's a 3.5 meg PDF. Sending it from. Let me send it from my analysis. It's sent from my Nalisway account. Sent.
Okay. Are you sending it now or the sent?
It just sent.
Okay. Yeah. It looks like it's updating my side. Give me one. I think. Yeah, it's receiving something. It looks like.
Oh, here we go. No, I did it. I obviously sent it from my OC project one.
Yep.
Okay, so you're going to get two. You're going to get one from my Nalisway now as well.
Okay. That's fine.
There we go. All right.
Okay, got it.
You got it. Okay, great. Yeah, so the research themes here, maybe just highlighting here, hardware technology, processor memory, disaggregated heterogeneous computing. So we're sort of in this disaggregated section here. These are the themes that they're talking about, and software. So compiler software stacks and programming models. I'm not sure if the control software, the system management software is featured in there, but I think there's a healthy desire for that for sure. So then the cross-cutting. So they've got this co-design of algorithm software and hardware, energy efficiency, reliability, resiliency, thermal management. So I mean, we roll in certainly energy efficiency, thermal management aspects, and certainly some of the co-design aspects as well, right, across the pieces. When you read it as well, a few items sort of jump out at you. I mean, so the other thing I also did.
So, go ahead. Sorry.
Yeah, no. Yeah, carry on.
No, I'm just trying to understand. If this RFP is for HPC only, or pretty much, because I can see storage and networking requirement as well, right?
Right.
So is it just how you're looking at is like multiple system, one system with the storage technology?
No, they are. This is various pieces of research. You don't have to do the whole thing. You just do it. You can pick certain pieces that you can do R&D in. But the idea is that these pieces of research will, depending on how well they go, will contribute towards the specification of the new exascale computer in the time frame of 5 to 10 years.
Okay.
So so it's like not looking at the next ones, I guess. It's just looking at the ones after that, saying we need to research new stuff that will then end up being part, or could end up being part of a new RFP for a new big machine in 5 to 10 years time.
Okay.
And the result is what do they call them? RBS, small business research grants.
I'm not sure. This comes straight from Oak Ridge National Labs, so I think this is. I don't think it comes under the SIBR program or BAAs. I think it's some direct funding from Oak Ridge National Labs or from DOE through Oak Ridge, because this has actually come from Oak Ridge, this proposal. It doesn't say.
So okay.
Have you presented your stuff, your proposal to these guys directly?
Well, we sent the one we did back in 2022. We sent a response to the RFI and that everybody contributed to. So that one's. Have you seen that one?
No, I mean, sort of like there should be like principal investigators that are driving this RFP.
Yeah. So the principal investigator is a guy called Justin Keck. He's a procurement manager at Oak Ridge
Okay.
National Labs.
And have you presented to him directly? Have you kind of met with him or know him?
The name doesn't ring a bell from the original RFI, but
Yeah.
basically.
And if procurement's kind of standing, so to speak, kind of administering it, which is very typical. There's some researchers behind it, right? So kind of at least in old previous experience from many years back, sort of the key is kind of getting into that group to where they know who you are. Either at a conference or something.
Yeah, well, I guess all of that feedback from the original RFI happened, and we had meetings and presentations and discussions. I'm just looking back here. Why can't I find?
Because let's say with node management or whatever, they probably have identified, sort of a specific issue that's a challenge going forward. And so the key is kind of understanding what it is they're trying to solve without boiling the ocean.
Right.
Yeah.
So that approach, I think, is when they actually specify a new machine. They say these are the problems we want to solve with this machine. But this is very much a broad research in all of the categories. So again, if you.
Yeah, I think that's what it is. This is kind of like Mitch, is that they're trying to define what the future is going to look like. Mm-hmm. So 5 to 10 years, that's in a computer term, that's pretty long term, right? So they're trying to see what is going to happen 5 to 10 years. So I don't think they understand these issues yet. They're just trying to define the hardware architecture.
Yeah, so Frontier was proposed like in 2012, 2010, 2012. And so it takes, and that's why they clearly, they'll have very specific, of course, it's pretty broad in the beginning because they want to do something new and different and so on. But they have ideas around where their shortcomings are today. And so then they'll be looking for folks to do this sort of work, but stay in their swim lanes, so to speak, and not.
Yeah. So, well, here you go, Mitch. Can you see this research and development theme? So in August 22, So that was back, this was one, they said in collaboration with the Asker Labs, they had this RFI that we responded to with the purpose of providing the DOE with information for planning DOE high-performance compute programs. The RFI responses highlighted numerous innovative ideas to address future HPC challenges. Informed by these responses to the RFI, the DOE drafted several broad themes for strategic research and development investment that will provide benefit to future extreme scale applications. And so that's where those topics come from. So that who may respond? Responders may include the vendor of hardware or software that could be deployed in a future advanced computer system. Examples include, but are not limited to, basic hardware components, memory, processors, interconnect, storage, vendors, system, compute and storage integrators, and software compilers management, system management. Hey, there you go, you're in there.
Yep.
Okay, vendors. Any company that provides the hardware or software relevant to delivering a multi-exaflop supercomputer may respond. So they're not looking for you to respond of, we're going to solve tomorrow's quantum chromodynamics problems with this system management hardware. So it looks like it's a piecemeal R&D effort to say, it would be great if the system management of our new machines was consistent across all machine vendors instead of a completely brand new one when HP deliver or IBM delivers or whoever delivers, having to start from scratch with the system management. One holistic, open sourced system management hardware, software would be ideal for these machines. And these are the features of the system management of these new machines, including like monitoring power demand at the millisecond level, let's say, is so that we can better control and understand where the energy is going.
Right.
So I do feel that, I mean, you probably want to read this in its entirety to get
Sure. Yeah.
the gist, but it does seem like, and so I've managed to find my damn email, which is good.
So the system manager perspective, Alan, I just want to talk to you about, right? Because if we want to respond to this, right, we need to understand what you have in the pipeline, what you are looking in the vision, right? What is the future is going to look like?
Yeah.
And so there is a lot more things happening. I don't know if you want me to explain what we are doing and what is the pipeline, but basically, in a very nutshell, there is two approach, right, on the system manager. One is like a completely zero trust, everything open approach, right? And basically gonna be, there is a clear trust organization that's gonna certify for that in a pipeline that we have. So that will be pretty much based on all open, open coding. It's everything in GitHub. It will have an ICE40. We're defining this as an X1 chip, which will have multiple ICE40 plus one ECP5 and some follow-up products after that. That's pretty much, it will be tamper-proof. We'll have ICE40, we'll have basically holding the keys. There is a proposal that we're putting together, has a small battery that's gonna keep the key in SRAM, so that way, you don't lose the key. So that's one path we're taking, and I can send you more details on that, Alan, when you need. We have a press release on that. And there is another avenue we're taking, is basically closed BMC approach, where the code, where basically we'll have, all the software IPs enclosed, right? So we have both of the avenues. So I don't know how we're gonna respond to that, but I'm just giving a heads up on what we have in our pipeline.
Right.
So does the Lattice part have a hardened CPU?
No. So so there is two things happening, right? Let me give you. So right now we'll have we have basically is a sub processor. It's what's that? It's It's Zydex or what? Anyway, it's an
Risk
embedded
five,
connector, so
Risk
yeah,
five maybe.
it's not RISC-V. It's a
Okay.
PowerPC architecture.
Okay.
But that's
Oh,
one
power. Okay.
avenue we are taking. Yeah, that's one avenue we're taking. It's pretty much, and if you look at IBM platform, IBM already has this, in their motherboard. There's some ODMs, multiple ODMs is designing the BMC, PowerPC-based BMC, and BMC of our device. That's already there. That's already there. That has most of the BMC functionality, not an 8-speed competitors. But then we have another device called X1, which is in a solid silicon is building. It's not our device, but it's pretty much our FPGA on that. The solid silicon is building. That is a zero trust. They're saying it's a zero trust. It's everything open, everything in the GitHub. But that's pairing with one or two FPGA device and basically some ICE40s. That's one route. And there is the one that we are working on, Alan, is that will have a processor. That will have an ARM processor, and that's going to be in by the time in 2025 or 26. So there is
so that's beyond Avant then.
Yeah, that's Avant plus we're packaging this together with Avant,
Oh, okay.
Yeah. There's another one. I still not sure about whether that's gonna be we're gonna have closer open architecture on that. So that's gonna be debating, but yeah.
Right. Yeah, well, I think the open architecture approach is going to be pretty key.
Correct. Yeah, and that's what I think Raptor and Solid Silicon is pushing for us. And I think what we're going to do, Alan, this is just we may release a version of Avant. I know that is, that's not going to be Avant, right? Because we're just going to change some of the gating, packaging, and all those things. So it's going to be different than Avant, but that way we can open it up without hurting our key Avant business. But that's the discussion, Alan.
And so your part can be a complete standalone BMC. It doesn't need to coexist with a BMC.
Right now, it is completely standalone BMC.
Okay.
And it runs open BMC, right? The software.
It's a standalone BMC is working as is right now. But what we're trying to do is that we're trying to add more component to the BMC so that we can provide a key management. Basically, right now, the BMC, there's no security of the BMC, right? If you look at today. So we're trying to put together ICE40 and FPGA together in a single package. And it's basically ICE40 holding the keys. That's one of the things that we have been working on. And it's not us who's working on, there is partners who are working on that. They already had a press release on this, and I can say more information.
Yeah, I did ping after your introduction. I pinged them. I remember now I didn't get a response. So I've not spoken to them.
Yes, Todd, he's the CEO for the CEO for that company. I can introduce you, Alan, if you want. And he has.
I think you already did, and I responded, but said, "Should we meet?" And I don't think
I'll ask Todd. Yeah.
Okay.
But he has a lot more in the pipeline, products in the pipeline that can be very beneficial for this particular.
And,
hi, John.
and
thanks for joining.
And these parts have Ethernet.
Yes.
And every how much
so right
do you
now,
have to add?
The one that we have on IBM board has Ethernet, has the remote management capabilities. It doesn't have KVM. I think it has USB. So I think the KVM is the missing one on that one. But most of the other things, so the fan management, firmware upgrade, logging, PICI, they don't have PICI because IBM is a different alternative than PICI, right? It's like FSI, FSI or something that's powerful than PICI, more powerful than PICI. But there's, the few things is slightly different when you look at Intel architecture, but other than KVM, it has everything.
And one CPU core, is that normally?
I think so. Yeah, I can get the details, but I think so. I can send a picture of probably the motherboard here. Let me see if I can find the motherboard picture here.
While you're doing that, hey, John, just want to say hi. Thanks for joining. Can you hear us? You're on mute, by the way.
Yes, I can.
Great. So actually, John, would you? I see that you do the hardware management for OCP over in another group. So would you mind just filling us all in on what you're doing there? Would that be good? Just a quick overview.
Yeah, let me. Okay, I'm actually trying to bring up a slide. But we try to deal with manageability across OCP platforms. We do a Redfish interface for remote management of the platform. So it's from outside to a Redfish service running on the platform, and that could be running within a BMC, which is an out-of-band controller, which is powered by trickle power, or it could be to an agent exposing a Redfish interface, which is running in-band on top of the OS. So that's one part of the work. The other part is on the other side of the BMC, from the BMC to each of the devices, the out-of-band management fabric to communicate management commands within the platform.
Right.
Redfish is REST-based, so it's fat, and the southbound interface needs to be very compact, very optimized.
Okay, and so that's basically all on the software side of the house in terms of the management, right?
No. So the northbound is software, because it's just a firmware running on a BMC or software running on the OS. On the south side, you have to get into hardware, and so the definitions are most of the systems are utilizing MCTP, which is a media independent transport layer, which runs on top of I2C, I3C, PCIe. You name it, it gets CXL, it gets mapped to various pieces of hardware wire, and then it transports messages. And those messages is defined as PODM, which is the platform level data model, and we have command constructs for CXL, for sensors, for firmware update, so on and so forth.
Right. Okay. Interesting. Okay, and so you work along with the DCSCM side of it,
Oh yes, DCSCM is within the hardware management module sub-project within our major project, and they handle DCSCM and they also handle RunBMC. So the difference between the two, both have a BMC, is the RunBMC has a SODIMM connector because they want something really, really small. And then later on came DCSCM, which actually has a SFF connector, which is more standard for the industry.
Right. Yeah. So, all right,
John, what did you say that the name of the SODIMM standard is?
Say that again?
What was the name of the project for the SODIMM BMC?
I've lost connection.
You said there was one that
Mike,
fits
if you're
into
speaking, I can't hear you.
I'm sorry, can you not hear me?
I hear you now.
All right.
Okay, my AirPods drop out every so often. So the one that you mentioned as the SODIMM connector.
Yeah.
Can you say the name of that project again? I didn't catch it.
It's called Run BMC.
As in RUN?
It's like RUN BMC. It's a playoff Run DMC, the group, the rap group.
Okay, and is it an ongoing project or is it a sunsetting project?
No, it's an ongoing project. As a matter of fact, I just left the steering committee where they updated the spec to 1.5.
Oh, great. So there's a
Yeah, and
is that a published?
oh yeah,
Is it a,
it's public. 1.0 is published, or 1.4.1 is published, and should be in the contributors database. There are 3 products in the OCP marketplace, which is a Run BMC product. And what I discovered today was that DCSCM has kind of migrated to servers, right? Because it's all part of the modular thing. And the Run BMC is actually migrating to networking products. That networking
Oh.
products have said, we don't need a
Yep.
DCSCM. We need a BMC. So we'll go ahead and add that. So
Okay.
those are where they're
Oh.
beginning to land as far as platforms are concerned.
Yeah, so the way I see this, John, is that so you're right? The Run BMC is on the Avenue City, which is Intel Workstream platform. There in the reference design, we already have the Run BMC connectors, right?
Okay.
Yeah. So
So
we
Manir,
have
then you have a Run BMC solution. Is that what you're saying?
Run BMC is purely a BMC connection. So basically,
Right.
the purpose of this one is that if you truly look at the reason behind this one, is that the BMC is kind of like a monopoly today, right? There's lot of interfaces, a lot of like legacy interfaces that BMC has that may or may not use. So Run BMC is basically trying to define a standardized interface of the BMC so that somebody else can actually play in the BMC market, right? So as long as they can fit in the Run BMC connector, so you don't have any more like the proprietary connection that actually today the HPD BMC has. So that's one of the solutions. But the contradiction here is that what John is mentioning, that so Run BMC already has a market, right? If you look at Intel Avenue City, which is 2 CPUs reference design that has a Run BMC connector. But the contradiction is the DCSCM. Actually, what the DCSCM did, DCSCM is separated the security control and security and management in a separate board, right? And the DCSCM has a BMC as well, but that the connector, the management and security is going to a separate connection called DCSCI to the management port. So that's what the slightly contradiction, because one way there is a Run BMC connector, which is basically putting BMC on a connection on a module where somebody else can actually work on, and the other one is the DCSCM, where you have DCSCI standard connection that actually pulls both the BMC and security together and talk to the HPM, right? So I think there is some contradiction happening there, but I think we need to probably, at some point.
So since this was presented just last hour, I've got the slides in they're actually now public. If you want me to go through them, I can quickly do that.
Well, it's Alan's meeting.
Yeah, no, this is good. Hey, well, actually, I'd like it to be somebody else's meeting. So, and Munir's.
Okay, so let me do that.
But yeah, no, I think this would be good for me and you, Mitch. I guess Munir,
Yeah.
you
Well,
understand
it's
the
right.
word.
Okay.
Yeah, it's right on topic with what I'm, my day job actually.
Okay. So this basically repeats what I just said. 1.4 is out. The scope is it was actually a planar in planar connector, which is why they went with the SODIMM. There are solutions in the marketplace from Intel and Hive. These are using ASICs. And then Meta has one which is deployed, but it's not on the marketplace, and they deploy it within within 2 of the platforms that they platform use or whatever, or they require that they be implemented. So Run BMC and DCSCM. So this is the size of a Run BMC. This is the size of a DCSCM. And as a matter of fact, if you see this little outline right here, that is a Run BMC inside the DCSCM. So this provides the original Run BMC spec only supplied BMC, right? And the DCSCM has a root of trust TPM in it.
It's got
So
2
this gives you-
FPGAs, 2 Altera FPGAs on it.
This is the way Intel implemented it and pushed the design out to a marketplace, because other people might want to run other things on their their ASICs, right? So Hive is a much I guess tighter.
So John, I think this is the Avenue City design that you just showed. So Intel has two reference design. One is 2 CPU, which is we just showed. But in the
Mhm.
single CPU design, they don't have run BMC connector.
Right. I know nothing about Intel platforms. They're a jumble mess to me. So yeah, so I'll
Yeah,
believe
no,
whatever you say.
so well, I guess just to get us back onto ours, I mean, so the run BMC is just a basic BMC for a to bring a module off of up and running, but it doesn't have the security features. So
Correct.
Right.
you go back
Right.
to
Its goal was platform vendors need to stop redesigning the BMC topology every time. Why don't we just concentrate
right.
it on this connector and plug it in?
Okay.
So Alan, I think the way I see that feature is gonna be, right? If you look at this diagram, right? If you look at, there is a BMC, we have a BMC connector. There is a security chip which actually has a PFR module, someplace here, not an Avenue City, but some other platform has. And there's some control mechanism because now you need to do a lot of serialization because you only have limited number of pins, DCSA pins that talks to the HPM, right? So there's some serialization, which is LTPI, that DCSA introduced.
right.
What I'm seeing in the market is that there's a lot of effort going on, especially for the hyperscaler, who are trying to combine BMC, security, and LTPI in a single package.
Right.
I think that's going to be the feature. I don't think feature is going to look like so different, what we're seeing today, multiple modules on top of modules, because if you see it here, there's a BMC modules on top of the DCSA modules, there are security modules on top of the DCSA modules. I don't think that's going to be there for 5 years. I think market is trying to pull all this in a single solution. So it will be DCSCM plus security plus any kind of serialization.
Right, and excellent to hear that. But just so I've got my head right, in a machine, like a high performance computing machine where you've got multiple nodes, the idea would be, or like a CXL, let's just call it CXL, so that's one, where you've got lots of infrastructure going on. You could have one DCSCM, which was the root of trust module that would talk to all of the other distributed BMCs in terms of security negotiation or setup. If I got that right, you would have one DCSCM and then the rest would be
How you decide to organize this is really up to you once you've got a group of systems, group of nodes.
right. Okay, well, so in my mind, the way I was thinking about this from our HPCM perspective, maybe if I can share my screen back to
Okay.
one that we've
John, will you be able to share this a link to this this deck?
Yes. Once it's been presented to the steering committee, it is public information.
Okay. Is it already uploaded or
It is not uploaded yet.
okay.
It's uploaded to the SC committee repository until it's presented. Then I'm sure I can point the person to release this to you, because from a OCP standpoint, it's now public because it's been presented to the SC.
Okay.
So I
Yeah,
will get you a link, whether it's I create the link or whether I go ask the originator. But I'd much rather he do it. Provide the
Okay.
link to you.
All right. Thank you.
Okay, just on this one here, first of all, on our module, right? We've got this array. We've got all of these. We have the HPCM module, which has one big processor or accelerator on it, and it has media modules plugged in, up to 16 media modules plugged in, and then it has cables connecting the modules together. There is no motherboard, right? So traditionally, your BMC would be on the motherboard, and you might have 2 Xeons and a bunch of PCI cards and the rest of it. And I was under the impression, with us going down this DCSCM route, it sounds like there may be other, like John was saying, there might be implementations where you have multiple DCSCMs, or I was assuming maybe we'd have one somewhere in the system. But so Manira, actually, I think what you're saying is you're planning on putting all of the features of the DCSCM into one device is ultimately where you're going.
That's what I'm saying. It's not only me. I think the industry is looking into that. So
Okay. All right. So
yeah.
Okay. So well, okay. In that case, then we can. But what we've got here is this is the architectural. This is the hardware piece that
Right.
been trying to lay out, and how do we, so basically, what we really need is we need each module to be able to standalone boot by itself. So it would standalone boot, and it could run an operating system, Linux, whatever, and it could be up and running and usable, without any other anything else being involved. So it's like a full-blown standalone server. We want a module to be able to do that by itself. But then as you connect modules together, they become one larger homogeneous system. And then the BMCs need to talk to each other in some fashion, in coordinate. And I guess you need a root. You need a root node that says, I'm the master of all of you. In terms of to bring everybody up, where there needs to be some negotiation to pull all of these together. So, so the key thing here is, so I've done this drawing. I've got a couple of examples of Power 10. This is from a couple of years ago when we did this, and Xilinx Versal or AMD Versal Premium FPGA is two examples. And this is also where Lattice have worked with Raptor and IBM, I guess, on a fully open sourced. So there's something called Libra BMC. Are you familiar with Libra BMC, Joe? The open hardware side of this? No? You're on mute, or
yeah.
So anyway, this is the open hardware implementation. This would be ideally where you've got all the RTL in an FPGA, and it could be anybody's FPGA, I guess. And I think people have done the Lattice and the Xilinx versions. So anyway, so working with Manure, we've come to this particular device, this Lattice Avant E30. Is where we're at the moment with these ICE 40s. These ICE chips are quite good in the fact that they consolidate all of these sideband IOs down to a single wire, and so that will, because we've got 16 E3 devices, we've got a ton of sidebands, a ton of I2C stuff in low and DC signals, etc. And so that allows us to really use quite a small device with fewer pins, and also and use these tunneling protocols to actually communicate and expand out to these sideband signals. So there's that side of it, and then we connect modules together with these topology connectors. So that we've got 4 at the top and 4 at the bottom, and I'm talking to the interconnect people of, ideally, we'd like to put either PCIe, CXL across these connectors, or it could be Ethernet between these connectors, or it could be NVLink, it could be XGMI, it could be anything going between these modules. And that what dictates the protocols on these interconnect is what processor or accelerator you actually put down on the module. So, but electrically and mechanically, they're exactly the same connectors. So because this is a communication between our own modules, I wanted to get rid of all of these sidebands. So Ethernet doesn't have any sidebands, for instance, whereas PCI has a bunch. So instead, I was thinking, if we just simplified to this new LTPI, which DCSCM is supported, and it's been opened up, is fully open from Lattice, that can go up to 1 gig, I guess. Is that right, LTPI?
Yes, it can go up to 1.2 gig.
1.2 gig.
Yeah.
So the idea here is that we would just go native LTPI between modules. So that's the theory. But the only thing then, well, the question is, would that be good enough for discovery and connecting all of these devices together by having an LTPI connection between all the HPCM modules? Or would we want, obviously...
I think you can have an LTPI. LTPI is a concentrator, right?
Yeah.
And
So let's talk about this, right? So Salah, let's not, and I think this is the bigger problem that OCP is trying to solve, where because LTPI today can only talk, 2 CPUs, right? It doesn't have capability to talk to more than 2 CPUs. And I think OCP DCSCM team is trying to put together something, the DCSM 3.0. I think they're looking at ESB or some kind of fan out interface to go multiple, So I think that's given, right? We're going to get it from OCP. So I think, we don't need to, we don't do it too much energy there, because we'll just accept what OCP has on that case, right?
Okay. I mean, again, these are going to be an LVDS pair, essentially.
Right.
So, I mean, the protocols can change.
Right.
I guess on the one front, my core desire right now is that we have all of the hardware features made, that we design them into the hardware of this, so that the software can evolve and the protocols can evolve inside that hardware. So I'm trying to think of everything we need to consider.
The one thing that I'm still seeing, that I'm just trying to understand how you envision this, right? Because this is a node. The way I see this one, that one you're showing is a node, right?
Right.
And this is the management of the node management that Lattice FPGA or anybody's FPGA can do it, which you don't need, because when you talk about this will go to a chassis, right? Let's assume that 4 of this goes to a chassis. So all the fan, all the remote management, all those things will be done from the chassis perspective, right? So the chassis need another BMC, and this, in that particular case, this BMC is going to work as a BIC, right? Baseboard interface controller, because it's the chassis manager who is going to be responsible for security, who's going to be responsible for your fan management, who's going to be responsible for all the operating system application, all this update and all those things. And it's going to push the data through that to this one, right? So that portion is not defined here yet.
So that's where I think we need to think about this, because there is no chassis. These modules will essentially be populated on the wall, and it'll just be lots and lots of this exact circuit being stepped and repeated on every module. Now, one of the modules, we could actually make an HPCM module, maybe that was like a head node, where maybe that's all it is. It's just a fairly simple HPCM module, but it's the one that controls everybody. It discovers, because you need to discover all of the HPCMs, and we need to discover who's connected to what. And so you do need one manager, and maybe that is an HPCM all by itself, a very simple HPCM. Was my beginning thinking on this.
So you need one manager to do the security, to do the power management, to do the firmware upgrade, application upgrade, OS upgrade, all those things, right?
Right. Yeah. So it was like maybe that's a module with a processor on it, or or one of these modules can suddenly, this is exactly the same design, but there's like a little jumper that says you are the head node of everybody else, and therefore it does all the work as a head node. I mean, we could do it like that as well, if that was one way to do it, and everyone else is configured as a device rather than a master, rather than a host. I don't know. So that's my thinking. Obviously, the connections between one module and any of its neighbors, or whatever the routing does with the cables to other HPCMs, is going to be defined through here, and that's going to be application driven. So these links, I was working with Munir on this, is this free. What we were thinking was, if we could have some free space optical connections, because this module goes onto a wall, right? So you guys,
yeah, but who is the end, your end receiver, right? The one that who is going to do all the network communication, the data moving in and out, right? That's going to be one of those the slots that I'm seeing, right? This network card slots. How it's going to be managed, right? Not from the internet side, not from the BMC side, from the workload perspective, from the application side.
Say that again.
So I'm assuming the right side, all the slots, these are for network cards, right?
No, these slots here are currently configured as E3.S's, so there'd be media, and in theory, well, you could use these as I/O as well, so they could be communicating I/O. You potentially could put a NIC card in there, but if you were bridging out, so you could but that we would need to do some modifications on some of the NIC cards. But or these chips, like if you put down a switch chip from somebody like Fabrica, then some of the ports on the switch chip are CXL PCI, and others are Ethernet. So you would, I envision you don't need network cards anymore in the ultimate when you get to this, because that we've got, so you would, the switches would convert you to the Ethernet world, or you would talk natively NVLink or whatever, depending on what device was actually put down. So yes, you could potentially have NIC cards in here as well. But I'm seeing these as mainly media, that they may have another port.
No, yeah, that's fine. I don't think you can define those things, but I/O from outside world, right? You're thinking about a CXL connection, right?
Right. So if you have a CXL connection, it could either come from one of these 16 connectors, if it was a cable, not media, or you could go over these topology ones as well. These could be PCI interconnect. So yeah, that would be your CXL connection, and you would need to do a discovery of who's connected via that. So these modules can be a switch as well. These don't just have to be processors. These can be switches.
Right. Yeah, also for discovery purpose, you need a head node as well.
Right, that's right. So I'm wondering whether we just have exactly the same hardware, but we have some way of jumpering to say this is the head node, so you can configure the head node in your system, and then it kicks everybody else off.
Okay. Yeah.
I think that would be the ideal way.
Yep.
But I guess that the only other thing apart from these connections, do we want like so I was thinking that we could have a 2D mesh, or even a 3D mesh, to as a separate control plane where everybody can talk to each other through the control plane, irrespective of what connections are here.
You're thinking about ICE4D NCSI connections, the network 2D connections?
This is NCSI,
right? This ICE4D NCSI band, right?
I'm not sure I follow you. Sorry.
So the ICE4D communicating to the lattice, these are basically NCSI band, right?
These were your single wire aggregator.
Right, with the
so that was just to reduce the number of IOs going into the main device.
Yeah, but this is basically to control the network devices.
Right. Yes. So these would be these would definitely be devices that are definitely controlled. These are more connections like between processors.
Mm-hmm.
So these so if they were PCIe, they could be non-transparent bridges, sort of thing.
NTP. Yep.
And but then it was whether we added an additional like an Ethernet, like a 1 gigabit Ethernet fabric with, so you'd have like a little switch functionality between the 4 ports, so that you'd almost built your own little control plane network on this at a 1 gigabit level. Was
So why do you need this NTP bridging, Alan? You just said that you need non-transparent bridging for PCIe. Why do you need that?
well, or however CXL is going to do it. So basically, you're gonna, like, you might have multiple modules could have processors in them, right? So, and they're going to have their own local devices, and those local devices might be visible to everyone else, right? So,
Okay. Yeah, if it is like multiple hosts looking at the same thing, I don't know. Yeah, today you do this, NTB, because you just do that address translation, but I'm not sure how CXL is going to do it.
Right.
Yeah.
Well, and there's a whole work group on that, right, as well.
Yeah. Let's not solve that problem.
Yeah. And Mitch, if you got any views on this? Assuming Mitch is still on.
Well, I think you've got a good start. There's a bit of factoring as to how much at what point. I mean, in other words, how large of a BMC do you need where? And then the challenging one is the fan out that you mentioned. Someone mentioned is some group in OCP is working on that, which they're thinking about USB maybe.
Are they thinking about USB? Really? Jeepers.
They're looking at USB as basically today, what's happening, Alan, is that LTPI can only take, this system can only take 2 nodes, right? 2 CPU nodes. And then there's requesting to have multiple. So they're looking at USB as a fan out to do that. I think that's what Tim Lambert is heading that way, Mitch, right? That's what you're saying. Because I talked to Tim Lambert about 3 weeks ago, and that's what he said to me.
So this is the challenge, and I need to track down this working group also. Tim Lambert.
Yeah, Tim Lambert is that. He's heading it.
USB is not the most ideal choice, but it's sort of.
And are they looking? What
there.
USB are they looking at? Are they looking at 40 gig or?
Probably not, but I mean, I've worked on a couple of systems that distributed USB, and it was sort of painful.
Yeah. Well, I'd have thought, if you're going to do it, I thought 1 gigabit Ethernet would be the best if you were going to do something like that.
What they're. I'll show what Tim is saying. Give me 1 second.
Well, Ethernet is lossy and not very deterministic unless you put protocols on top of it.
Right.
Yeah, so what he's saying that multi-node, we're looking into more than 2 node support for various CPU types. USB 2.0 is looking like a popular choice to replace some of the legacy interface. I would see LTPA playing a similar role as 1-2 node LTPA or GPIO. If the PGA has, so he's saying basically more than 2, he's looking at USB 2.0. It's not, it's not done yet, but that's what Tim Lambert is looking.
Yeah, but there's not really that. I mean, that's the 2. There's really very few choices, and sort of from a system design, particularly whenever you get to a large system like this, where you have lots of domains and so on, it's crossing a power domain is really challenging because of the common mode differences. And that's
well,
what,
so
that's
so
what
this is where this optical mesh.
Well, it's in its infancy, Alan. I like it, but I like the idea. but it's probably got, 5 years of hardening.
Yeah.
And then who wants to be the first one to shoot with production?
But so
That's
when you
always
say about the common mode, I mean, yeah, obviously that's a bit. I mean, I come from a military world, so I know all about the ground loops and all the rest. Between
yeah, I mean that's it's kind of trivialized. Oh, it's just a ground loop, but
no, it becomes huge.
Yeah,
yeah.
And I can I don't want to mention the company, but there's a company with a self-contained system, that's got, it's like a blade chassis of sorts that's up, north of, around 20,000 watts or so. And you just end up with these challenges whenever you go across power domains. It's bad enough whenever you go across a connector in a system with something like I²C.
Yeah.
And so you go differential and you get a pretty good common mode rejection, so long as you don't violate the common mode range. But when things go south or misbehaving,
yeah,
or transients get coupled onto the lines, you get these issues. And that's what's golden about Ethernet, is that it's got 40 years of whatever of being of having complete isolation, other than it's not quite optical. But other than that, it's very, very tolerant.
That's his transformer isolation.
Right.
Mitch, I need to drop out. Can you talk to Tim Lambert on this one, please, on USB, if you don't agree with that?
I have to drop.
Yeah.
Yeah, I have to drop also. But
talk
if I get a pointer, I'll try to track down that work group.
Yeah.
But
if you want to pull me in, fine, or you can just send me directly the message. Yeah, it's up to you.
Yeah. Okay. Interesting. All right. Well, good.
And let's talk about that in a separate meeting too. I think I have some more feedback on that, but whenever you have some time, we can talk offline.
Yeah. Okay. All right. Thanks, guys.
Okay. Thank you, man.
Okay. Thanks. Bye.